Welcome, everyone, today to the Testeract webinar. My name is Jason Wilkinson, and I'm your host. For this webinar, we have Matthew Greenwood from MacPanel. He is the marketing director at MacPanel and has been working in the automated test industry for 10 years. And he's going to be addressing mass interconnect and how you can use it to create more robust automated test systems. So at this point, I'm going to hand it over to Matt, and let's hear about it.
Sure. Jason, thank you so much for having me on this episode. And for everybody listening, I really appreciate you guys tuning in and listening in. I'm going to pull up a slide deck. I don't want to bore anybody, but it'll help at least guide us along. Here it is. So yeah, like I said, Jason, I really appreciate you having me on this episode or this webinar. As you said, my name is Matthew Greenwood. I'm the marketing director for MacPanel. Some of you might have heard my podcast, MacPanel Test Connect. The most recent episode that we had was with Jason and with Clint Biggs with Testeract, and we actually went over how to reduce cost and also looking at price when building ATE systems. If you haven't heard that podcast, I would highly encourage you to go listen to it. You can find it on MacPanel's YouTube channel, our homepage of our website. Testeract has it, I believe, on their LinkedIn page, and then also a page on their website as well that I'm sure Jason will send out after to each attendee after this webinar. So I appreciate you listening in today. Like Jason said, I've been in the industry for about 10 years, specifically working with MacPanel. So I know ATE, and I know ATE in regards to interconnect solutions. So MacPanel is recognized as the expert in ATE interconnect solutions, okay, by many entities. We specialize in providing innovative and reliable interconnect solutions that meet the diverse needs of our customers in various industries. Our goal is to enhance the efficiency and performance of your test systems by partnering with you to provide you with interconnect solutions that meet your testing requirements. I'm excited today to kind of share with you some of my insights into how mass interconnect can play a crucial role in building robust automated test systems. So let's get started. So before we dive into the details, let's set the stage for what we'll be discussing today. Our focus will be on mass interconnect systems and their crucial role in automated test equipment, or ATE. We'll explore the various types of mass interconnect solutions, their benefits, and how they compare to traditional methods. We'll also look at real-world case studies to see how these systems are applied in different industries. So I'd like to get started with an analogy, and one that a lot of folks, specifically that work at MacPanel, work with MacPanel, use. So the analogy is, imagine two cities separated by a river. Okay, and to connect these cities and allow for the flow of traffic, we would build a bridge, right? This bridge serves as a vital link, enabling communication and exchange between the two sides. In the world of automated test equipment, or ATE, mass interconnect serves a similar purpose. It acts as a bridge between the device under test and the tester. This bridge allows for flow of signal, power, and data, ensuring that the testing process is efficient and effective. Just as there are different types of bridges designed for specific purposes, such as suspension bridges for long spans, truss bridges for strength, and girder bridges for shorter spans, there are also different types of mass interconnect solutions. Each one is designed to meet the specific requirements of different testing environments. The key is to choose the right bridge, whether it's traditional or advanced mass interconnect systems, to ensure a smooth and successful connection between the device under test and the tester. So I'd like to start by understanding what we mean by mass interconnect. Okay, so in the world of ATE, mass interconnect plays a crucial role. It's like a bridge, like we stated in the analogy, that connects the device under test to the tester, allowing for communication and data transfer between the two. Think of it as an infrastructure that enables the flow of signals, power, and data. It's modular, rugged, and highly reliable and configurable, making it a versatile solution for various testing environments. With Mass Interconnect, we can achieve reduced setup times per test application and increase signal performance compared to traditional cabled approaches. So this is what a traditional or a mass interconnect system would traditionally look like. Okay, you have the interchangeable test adapter here, a device under test. You would have the ITA frame. You'd have ITA modules and receiver modules, along with a receiver and the test station. So moving on. So now that we have a grasp on what mass interconnect is, let's delve into the different types of mass interconnect. Broadly speaking, we can categorize them into two main types. You have traditional mass interconnect and advanced mass interconnects. So let's dive a little deeper into traditional mass interconnect systems. So these systems are typically more straightforward with a generally lower upfront price. They use contacts, modules, and cabling to bring out signals between the instrumentation and DUT. They're versatile and can be used for a broad range of applications. However, their performance can be limited due to the use of cables. Additionally, maintenance and scalability can be challenging with traditional mass interconnect systems, and the overall cost may increase over time due to these factors. So looking at the features, traditional mass interconnect systems are known for their generally lower upfront price, making them a budget-friendly option when considering price upfront. However, their implementation can be a bit longer due to a straightforward but sometimes time-consuming approach. One of the limitations is signal integrity and performance because of the use of cables, which can be inevitably lower. This also impacts scalability, as it can be challenging to expand or modify these systems. Debugging and maintenance are similarly time-consuming and challenging, again, due to the reliance of cables and limited access to the system. Flexibility is another area where these systems may fall short, as they can be difficult to reconfigure for different testing requirements. While the initial price might be appealing, the overall cost, including design, build times, and ongoing maintenance, can be higher in the long run. So I'd like to move on now to advanced mass interconnect. So advanced mass interconnect systems are the evolution of test connectivity, offering an innovative leap into modular ATE platform performance, like PXI systems. These systems strategically minimize cable assemblies, introducing PCB-based direct access kits and pull-through adapters to enhance connectivity, signal performance, and signal integrity. Their modular nature allows for swapping out PCB connectivity swiftly, streamlining the setup process for various tests. This design ethos is not just about flexibility, it's also about scalability, adapting as your test requirements evolve. This method is ideal for ever-changing landscapes of dynamic and robust testing environments. These systems meet the stringent demands of industries like aerospace, defense, electric vehicles, and the medical field. So again, looking at the features, advanced mass interconnect systems represent a higher initial investment, but pay dividends in their swift and efficient implementation. The design and build phase, often just a matter of hours or days, stands in stark contrast to the more extended periods required by traditional systems. With a core focus on signal integrity, these advanced systems offer superior performance due to their reliance on PCB connections rather than cables. Scalability becomes less of a task and more of an intrinsic benefit, thanks to their modular design, which allows for easy system expansion and reconfiguration. Maintenance and debugging are also streamlined by this modularity, which cuts down on both time and complexity. So flexibility is another hallmark of advanced mass interconnect, enabling quick and effortless adaptation to new testing parameters. When considering the overall cost, the upfront price is balanced by a reduction in assembly and maintenance efforts, resulting in a cost-effective solution over its lifespan. So I'd like to get into, this is a question that we always get, right? So which one is better, traditional or advanced? And looking at the unique nature of testing applications, we can come to understand that each one presents its own set of complexities and challenges. There's no universal interconnect solution that fits every scenario. Optimal results are achieved through a specialized approach, tailored to the specific demands of the application at hand. So next, I want to explore two specific case studies that illuminate the practical applications and benefits of each type of mass interconnect. These real-world examples will help us to see how both traditional and advanced mass interconnect solutions can be deployed effectively to meet various needs of different testing environments. So getting into it, the first case study that we'll talk about is for traditional mass interconnect. In this scenario, our client, a contract manufacturer in the aerospace and aviation electronics sector, faced challenges with their direct wired and cabled connection. This setup required time-consuming manual configurations for each DUT. To enhance efficiency, they turned to Mac Panel for a solution that minimized manual efforts. So what did we do? Mac Panel implemented the use of interchangeable test adapters, or ITAs, as shown here, within a traditional mass interconnect system. This approach allowed our customer to swiftly swap out DUTs, significantly reducing test changeover times and simplifying the overall process. Our next case study will highlight advanced mass interconnect. So for this case study, we will talk about a partner that we have in the medical device sector. They approached us with a clear objective to produce for them an interconnect system that could be cloned for use in multiple, approximately 20 or so, duplicate test stations that would be deployed worldwide. This level of replication across the globe required an interconnect system that traditional methods could not support, as cables can introduce a host of challenges, from signal integrity issues to the logistics nightmare of maintenance and calibration at a global scale. What they needed was a solution that could provide the same high-level reliability and precision at each of their stations, irrespective of location. A system that supports quick and efficient changeovers, and one that could be transported and set up without the burden of recalibration every time, or worry that the interconnect approach would create signal degradation due to the transportation of the system. So, in response, our solution was to take a hands-on approach. We worked side by side with the customer to fully grasp the requirements and tailored our advanced mass interconnect system to meet those needs precisely. Our solution was designed to tick every box on their list: reliability, the ability to clone setups for global deployment, ease of transportation, and the simplification of setup and changeovers. Our collaborative effort resulted in a system that not only matched their high standards for testing, but also brought additional benefits. The advanced system streamlined maintenance processes, significantly cutting costs and allowed for a swift global deployment, thanks to its design optimized for quick and straightforward setup. But I want to say that advanced mass interconnect systems are often associated with PXI platforms, but their use extends virtually to all modular platforms, as is evident with the concept drawing shown below for SLSC. This broad applicability signifies how advanced mass interconnect systems, like Scout, are crafted to support a wide array of testing platforms, enhancing connectivity and flexibility across various industries, whether it's aerospace, automotive, defense, consumer electronics, or healthcare. These systems provide a modular, scalable solution that meets the rigorous demands of complex testing environments. So, choosing the right interconnect solution really comes down to one thing: partnering with experts who have a track record of success. At MacPanel, we bring decades of expertise to the table. By working with us, you're not just selecting a mass interconnect system, you're gaining a partner dedicated to your success. As Testeract knows, we have worked with them on several projects. And every time I believe that we've met and achieved and exceeded their expectations. I'm sure that Jason will add to that. So again, I appreciate you, Jason, allowing me to be a part of this webinar, and I'm going to hand it back over to you.
All right, thanks, Matt. And if you've got, so Matt and I are going to be on chat for a little while. So if you have any questions about any of this stuff or any of the other things that we do at Testeract, we make mostly test software, but also partner with people like MacPanel to make complete test systems. If you have any questions about that or anything else, then please feel free to ask them in the chat. And thank you for attending.